Welcome back, everyone. Today, we're diving into an absolutely fascinating explainer that's going to challenge pretty much everything we think we know about cognitive processing, attention deficits, and how the mind actually interacts with reality. We are getting right down to the core of how a specialized 4D visual spatial mind operates. And more importantly, we'll see exactly why forcing that kind of mind into standard, low-bandwidth environments causes, well, catastrophic system crashes. Okay, let's dive into this with a really profound insight from UC Berkeley educator Frank Coyle. He hit the nail on the head when he noted that a core feature of high-dimensional intelligence is that, as he puts it, we hallucinate in a way. We imagine things that may not exist, and then we turn them into reality. Think about that for a second. In this context, hallucinating reality isn't some sort of glitch or error. It's actually a high-performance feature. It's the exact mechanism we use to project structure onto the world right before we physically build it. And that exact concept brings us to the biophysical definition of what we call your daimyon, which comes from the Hebrew root for imagination or resemblance. Now, your daimyon is absolutely not an idle delusion or some random daydream. It is your counterfactual bridge. You can think of it as a perspective engine that is actively modeling your unshielded starting coordinates, basically how you're about to physically interact with the raw, unfiltered world right in front of you. Your brain, point blank, refuses to be an empty container. Instead, it proactively shapes those physical coordinates, transforming pure potential into a compiled physical reality on your bare biological hardware. So the crucial point here is how perfectly this daimyon connects to Coyle's whole educational philosophy. Nothing is mistake, there's no win, no fail, only make. When you're operating under this paradigm, you just completely bypass the slow, highly judgmental, symbolic systems, the grading swamps of standard society. You aren't trying to win a verbal debate, and you certainly aren't accepting a clinical fail. You just make. This is what we call a somatic compile. It's taking a thought and turning it directly into a physical action that engages your entire sensory system. The physical action literally becomes the algorithm. But what happens when this naturally fast system gets blocked? Let's look at a structural comparison. On one side, we have the 4D visual spatial mind, which operates with beautiful, zero-latency geometry. On the other side, we have what we affectionately call level 3 bubble sort hell. This is that agonizingly slow process of being forced to do things step by step when your brain is naturally screaming to see the whole picture at once. Let me give you an example. There was a twice exceptional 4-year-old boy from Nice, France, whose nursery teacher forced him to trace simple dotted lines. Now, for a mind engineered to manipulate 4D spatial variables, like his dinosaur toys, this sequential compliance was literally a metabolic torture chamber. When you force a high-bandwidth mind into a low-bandwidth environment like that, it causes severe system jitters and an exhausting translation tax just to survive the space. Now, what's really interesting about this slide is how perfectly computer science maps onto human biology. Take a TPU, a tensor processing unit built for massive data. It uses a just-in-time or JIT compiler to turn code into instant machine language. Well, in your brain, your counterfactual bridge acts exactly like this JIT compiler. When a TPU's data shapes suddenly change, it throws massive latency spikes, which developers call jitters. In human biology, the translation tax of dealing with clunky, low-resolution social noise causes those exact same biological jitters. But when the system perfectly aligns, boom, you get a smooth, zero-latency somatic compile. This brings us to a fascinating concept we call the God view and Pythagoras' dinosaur. You see, to Pythagoras, raw, chaotic human desire, what we might call our inner dinosaur, or the wildness of Dionysus, was not a clinical error that needed to be filtered out. Not at all. It was a high-fidelity anchor. By mapping that high-entropy parallel desire directly onto the physical hardware of the universe, Pythagoras escaped the text-bound administrative swamp entirely. He compiled his reality directly onto the earth. If you want to tap into this God view yourself, you need to execute what we call the beta special moves. First, you have to escape the 2PC trap. That's the two-phase commit that freezes your whole system while it waits around for outside permission. Second, you deploy bimanual coordinates. Picture software engineer Tom Hennigan bouldering at King's Cross. He uses incredibly precise bimanual coordinates to navigate that physical wall. In doing so, he proves he's absolutely not an empty container. He's actively running the physical math with his environment. Third step, you anchor to a global constant. And finally, fourth, you use that structural reality to literally outboulder the swamp of social noise. And this brilliantly illustrates how anchoring to a global constant actually works. Mathematically, it's represented as G-best, or a global best anchor. When you anchor to someone operating with perfect structural consistency, like Tom Hannigan on that bouldering wall, your planned actions behave exactly like visual CS50 scratch blocks. They just snap together flawlessly on their grid. Because the meaning is inherently built right into the structure, this geometric snap instantly releases the central cognitive bottleneck in your brain. It flushes out trapped thalamic cortisol and restores a beautifully smooth, focused brain rhythm. When those cognitive blocks snap together perfectly like that, your translation tax drops to exactly 0.000. There is no latency, zero delay. Because the physical action is the algorithm, the unflattened structural fit is so perfect that the high latency prefrontal tax you usually have to pay just to explain yourself to the world, it completely vanishes. This creates a massive paradigm shift in how we fundamentally view the brain. Standard clinical models spend all their time focusing on impairment, how clumsy societal rules freeze the system and cause a biological shutdown via selective inhibition. But this architecture flips that entirely on its head. It focuses purely on pairing. It's all about finding that uncompromised, zero-latency, somatic alignment where your internal geometry perfectly matches an external constant, bypassing that nervous system freeze altogether. Let's move to some recent groundbreaking research from MIT and Princeton and see how this builds into the exact opposite focus of those traditional impairment models. They discovered that the brain actually uses cognitive Legos. These are reusable working memory circuits. The parietal cortex specializes in holding sensory input, while the prefrontal cortex dynamically repurposes those exact same neurons to store action plans, meaning your brain doesn't have separate isolated circuits for every single task. It uses flexible pairing. It repurposes identical neuromodules to execute uncompromised pairing right on your bare hardware. Now, this incredible cognitive flexibility leads us directly to what we frame as the TechFlix and rational BJIT negotiation loops. Essentially, this is the continuous loop of balancing your internal processing with external reality. In a high-dimensional mind, your biological just-in-time compiler relies on this flexible pairing to negotiate complex realities. And because true structural pairing always takes two into account, it's a perfectly balanced equation. It's exactly like how a true boulderer navigating a wall is always an accountant for, calculating vectors, preserving energy, and ensuring the math balances perfectly between themselves and the stone. Which leaves us with this final, really vital question to ponder. Is your brain actually suffering from an attention deficit? Or is your twice exceptional mind simply a highly optimized, high-performance engine that's just been running on the wrong fuel? You see, when you finally find the right global constant and trigger that just-in-time compile, the latency just vanishes. You aren't broken. You might just be waiting for the right geometric snap. Thank you so much for joining me for this explainer. And hey, keep questioning the grid.